Now we're going to talk about, well, what if the function doesn't go all the way to the axis? What if there's going to be a gap in your solid? So for example, if you're trying to, okay, so here's the region. You are trying to rotate this around the x-axis. You'll get something like this. You see there's a hole here. So the volume of this solid is the volume of like everything under this function, but minus the area of everything under this function under here. Because there's this hole right here. So if we go over here, so the main formula to use for this washer problem is, it's called a washer because if you know like a washer, like it's what it looks like. It's like a figure with a hole in it. So if you slice this up into different sections, you get a whole bunch of different sized washers. Areas of each of these washers is like the integral, the area using this as a radius, your larger function, minus the area under this function, under your like lower bound function. So it's a lot like finding the area of the region, but now we're finding the volume of it. So the volume is pi times the integral of this big R squared, which is your function that is the top radius, the top bound, which is your top function, minus your lower radius, your lower bound function, squared. Dx, and keep in mind this dx is when you are slicing vertically. So these slices get smaller and smaller relative to the distance x. So dx is for when you're rotating around the x-axis. You are going to use dy, like in the second example, when you're rotating around a vertical axis, like the y-axis. But since we are going to rotate this region about the x-axis, we're going to use dx. And now we'll set up our integral. So the volume of this solid obtained by rotating this guy around the x-axis is pi times the integral. Now our bounds, remember we're dealing with x, so it's going to be our x bounds. So the bounds of these, the intersections of these functions is when x is 0 to x is 2. So that means the limits of our integral are going to be 0 to 2. Of your outer bound function, your big R, is going to be your top function, which for us is 2x. And our lower radius, our smaller radius, the inside radius, is going to be our lower bound function, which is x squared. So if we, take a look at this formula up here, it's going to be volume is pi times the integral of your lower limit to your upper limit of your outer radius squared minus your inner radius squared. So for us, that is going to be 2x, Make sure you square the whole function, which includes the 2. So 2x quantity squared minus x squared squared dx. Alrighty, so we'll do this one by hand. So this is going to be pi times the integral from 0 to 2 of 4x squared minus x to the 4th power dx. Now we'll integrate, so we got pi on the outside because you can pull out constants when you integrate, of, let's see, the integral of 4x squared is going to be 4/3 x cubed, minus the integral of x fourth is 1/5 x to the 5th. We're going to evaluate that from 0 to 2. So, fundamental theorem of calculus says that we first plug in a 2 for all of our x's. This is going to be 4/3 times 2 cubed minus 1/5 times 2 to the 5th. Okay, we'll make even bigger brackets. Minus, plug in 0 for x, but if you notice, this first term becomes 0 minus the second term becomes 0, so you end up just subtracting 0. Alrighty. And then if you simplify this, you end up with pi times 64/15. If you have any questions at all about simplifying this, just shoot me an email, okay? But that will be the volume of this region when you rotate it around the x-axis. Will be pi times 64/15 cubic units. Pretty cool, huh? So now let's take a look at an example of rotating something around the y-axis instead. Because this y-axis means that our radius is now going to be horizontal. So we're going to look from this function to this function. So our circles will be these horizontal lines now. And so this y-axis means that we're going to integrate with respect to dy, which means that all of our functions have to be written as x equals something. So this means that all of our functions have to be written as x equals. So this y equals cube root of x. We need to write this as something like x equals. So if we take we cube both sides, we get, on this side we get x, and we get y cubed. And then y equals x to the 4. And to make this be x equals something, we multiply both sides by 4, so this is actually x equals 4y. And now these are the functions that we're going to use when we integrate, because we're dealing with dy, so that means our variable has to be y that we're integrating. And since we're rotating around this y-axis, our bounds are going to be in terms of y as well. So take these intersection points, our limits, our integration limits, are going to be where these intersect with the y values of where they intersect. So these limits are going to be 0 to 2. And lastly, we need to share which of these functions is the outer radius and which one is the inner radius. So if you can picture this, as you rotate this around the y-axis, if you can picture this, it's honestly, for me, I have a hard, okay, so I'm going to be honest with you. One of the hardest parts for me in calculus is visualizing these rotations. So if you're like me, this is hard for you. So I find it easy to physically tilt my computer or my screen or my paper to figure out, as I rotate this, which equation is the top radius. Which of these functions is our top value function? And if you can see it, it is this one right here, which is our 4y. So that means this guy is our outer radius, and this y cubed is our inner radius. Now we can use our volume equation. So volume is equal to pi times the integral of our limits from 0 to 2 of our outer radius squared, so 4y squared, minus our inner radius squared, so y cubed squared, dy. And at this point, you integrate just like you would with respect to x, except it's y now. So let's see, we got pi times the integral from 0 to 2 of 16y squared minus y to the 6th dy, which equals pi. Let's actually integrate now. So this is going to be 16 over 3 y cubed minus 1/7 y to the 7th, evaluated from 0 to 2. And when you actually evaluate, alright, I will erase this and we'll do one more step here. So now, fundamental theorem of calculus, sorry, I'm writing back up here. So pi times 16 over 3 y cubed, so 2 cubed, minus 1/7 y to the 7, so we're plugging 2 for y. This is 2 to the 7th power. And you would subtract when you plug in 0, but if you notice, everything turns to 0 there. So we're just left with what is right here. And when you simplify this, you get pi times 512 over 21. So the key difference here with this around the y-axis problem is that your functions have to be in terms of y, which means you have to solve for x, and you're going to integrate with respect to y, so we're going to have a dy there. Your limits are also in terms of y now instead of x. So that's it for these washer problems, and that's actually it for solids of revolution. So please email me with any questions that you have. On the next page, there will be a couple of extra resources for you to look through if you still feel like you need a little bit more practice with this concept. But email me with any questions that you have, and have a good week, everyone.